Hello, this is Greg Labarge, Field Specialist in Agronomic Systems with Ohio State University Extension. This video we want to walk through the process of developing a tri-state fertilizer recommendation for phosphorus, working with our field crops here in the state of Ohio. Want to get you having a better understanding of how to come up with a nutrient recommendation, and then from that nutrient recommendation how much fertilizer actually has to be applied to meet that nutrient need. Sometimes we will see coming from the lab when we look at the soil test report a set of recommendations on that report. One thing I want to just alert you to is that there is no regulation or rule from any authority. In other words, Ohio Department of Agriculture, Ohio Department of Natural Resources, or any other entity in the state of Ohio does not require that that recommendation be done by any certain standard. In other words, you need to take a look at that report form and in particular the recommendation on it and know where that came from. You'll want to check with the lab if it's in doubt as to what the source of the recommendations were. If you were looking for a tri-state fertilizer recommendation, you'll want to do a comparison, because we have had some folks send in their samples to a lab. They asked for a tri-state fertilizer recommendation to be generated, but when they double checked the information that they got back, they ended up with something other than a tri-state recommendation. In other words, the numbers didn't match up to the process that we're going to talk about in a few minutes. Everybody can make data entry errors, and likely that is the case, that somebody checked the wrong box to generate those recommendations at the lab when they were doing the data entry. So take a good close look at the phosphorus recommendations you see on any report form. Do a double check if you're not familiar with the source, just so you understand what your recommendations are and understand how they will potentially work in your production system. Really, when we talk about making a fertilizer recommendation, we need three things, and these are the three that we'll need. We need a representative soil sample from the field with a Bray P1 or equivalent soil test done on it. We want to have a realistic yield goal for the field based off of recent production. It can be something like the last 5 years, throwing out the high and the low year. Really, however you determine what a realistic yield goal is for the field, because when we talk about phosphorus here, we're talking about still a yield goal based system. The final thing that we need is a recommendation table or a tool such as a spreadsheet that has fertilizer recommendations that are calibrated to the soil test and the crop yield of the target crop. So that's the third characteristic that we're going to talk about, and today we're going to use the tri-state fertilizer recommendations as that calibrated source for crop yield and soil test level. So we're going to walk through an exercise here, and the goals of this exercise too, as we have in the series, is to make an appropriate nutrient fertilizer recommendation from a couple of example fields. If you've not done it already, you will want to stop the video, go back to the website, and download the 6 pages for exercise 4, and I'd suggest printing them off so that you can kind of walk through the exercise with me here today. And we said earlier we needed 3 pieces of information, and what you have in front of you on the example 2 printout is a soil sample report, one component that we certainly need, and we're going to really focus in for the recommendations that we want to generate on field 2 and field 5, as you see in front of you there. So we can look at the soil test level. For the phosphorus soil test level, they're reported as a Bray P1 in the units of parts per million. We have a 9 value reported for field 2 and a 24 for field 5. If you have any doubts or don't understand what we were just talking about with Bray P1 and parts per million, how that all works, we do have a video, which was exercise 1, that walks through reading a soil sample report for phosphorus, and would suggest going back and reviewing that if you're not understanding why that is so critical in developing our recommendation here. The other piece of information that we need is yield goals, and what you have here is we're going to use field 2 and field 5. We have for the 2016 year a 170 bushel goal for field 2. Soybeans the following year is going to be 45. The field 5 is actually a little higher yielding field for us and has 250 as far as our yield goals for corn and soybean are concerned. Then the recommendation source that we're going to use is the Tri-State Fertilizer tables. We actually have those printed off for you on page 3 that you can use with the exercise here as we go through it today. If you look at the top of page 2, we actually have kind of a little report form that we can walk through, generate the information in relationship to understanding what crop needs we have here or excuse me, the fertilizer needs that we have here for a 2-year rotation that we're going to put down. Actually, what we have here is 2016-17 recommendation needs for the soil test level of 9, and we have can go back to that table 13 and pick out the corn information that we need to come up with that recommendation. The soil test value here is in Bray P1 parts per million, so we want to be in this column. We don't have a 9 number, but for today's exercise we'll consider 10 close enough. For that field we have a 170 bushel corn yield goal, and so we follow that across, and our number becomes for the recommendation a 90 phosphorus P2O5 recommendation. If we follow that through to our record page here, we can look at this and see that we added a 90 here. If we don't have in the presentation here the table 15, that is the recommendation for soybeans, but if you look at the table 15, we do the same method here of looking at the Bray P1 column for 10 parts per million. We follow that across for a 45 bushel soybean yield, and what we end up with is we have 40 and 50 as far as the yield here, and the recommendation is going to be 55 or 65, and we can kind of average those to come up with that 45 bushel yield. So our recommendation for soybeans would be 60 in this case. Now let's take a look at field 5 and determine the nutrient need for that field. As a reminder, we have a 200 bushel corn yield goal for 2016. We have for the 2017 bean crop a 50 bushel per acre yield, and our soil test value is 24. Taking a look at table 13 again and following across, which in this case we're talking about the corn fertilizer need, we have a value here of 24, which falls in this range because of working with a Bray P1 soil test. We follow across and our yield goal is 200 for this field, and we have then a ability to pick out a 75 pound P2O5 recommendation for the corn crop. We go to table 15 and we can look across again. We find that area that we have the Bray P1 test 24, follow that across to a 50 bushel soybean yield goal, and we see that we have a intersection where we have 40 pounds of P2O5 per acre recommended. Add 75 and 40 together gives us a total recommendation of 115 if we're putting down a 2-year application of phosphorus. Now we know that fertilizer is not a pure substance, so when we were talking earlier about needing 150 or 115 pounds of P2O5, that's not what we're going to put down as far as fertilizer content. These are the sources of fertilizer that we have available to us. The common ones that we're working with today are either monoammonium phosphate or diammonium phosphate. In this case, what we're going to use for our fertilizer source is the MAP, or monoammonium phosphate, which is 1152O, in meeting our fertilizer need for the recommendation that we have for nutrients. So what we do here is we carry that 150 total that we have for field 2 down to our fertilizer need area. We have a nutrient recommendation once again of phosphorus elemental, or excuse me, P2O5 of 150 pounds per acre. We have our fertilizer source is 1152O MAP. We take 150 divided by the percentage of nutrient that is in this case nutrient being P2O5 in our 1152O, which is 0.52 or 52%. We divide 150 by that 0.52, and what we end up with is 288 pounds of 1152O needed in order to meet our 150 pound phosphorus nutrient recommendation. Something we need to think about, particularly with MAP, is that MAP or DAP, is that we have a extra nutrient coming along with that we're paying for. We actually have, in this case, with the application rate that we're talking about of 288, MAP is 11% nitrogen. 11% times 288 gives us 32 pounds of nitrogen. Depending on how we're using this could be some top dress nitrogen for wheat. Maybe if we've spring applied and banded, we actually can use that as a replacement for starter fertilizer. But if we've surface applied that nutrient in the fall, we know that that nitrogen isn't going to be around. Depending on what current nitrogen prices are, that 32 pounds has some economic value. Does that economic value start to pay for some different placement tools on our farming operation if we can take advantage of it? Kind of a future to think about type of question as we look at these nutrient recommendations and what actually is being applied. Let's do the same to come up with the amount of fertilizer needed for field 5. Here we have a 115 pound nutrient recommendation. We're using our 1152O. 115 divided by these percentage, which is 0.52 of P2O5 in our fertilizer source. We come with a recommendation of 221 pounds. In this case, our 221 pounds, 11% nitrogen, we have 24 pounds of nitrogen, depending on how we're applying it, that we may or may not have available as far as crop production is concerned. So in summary, that's the process that we go through, and as far as making a nutrient recommendation to come up with the pounds of P2O5 needed, and then coming up with the fertilizer recommendation based off the source of nutrient that we have. Once again, for the recommendation part, we do need to have a representative soil sample with results that have a Bray P1 or equivalent soil test value to it. We need to have a realistic yield goal for the field, and then we need to work with that recommendation table that is calibrated to the soil test level and crop yields of our target crop. When we are using commercial fertilizer, in this example, what we're thinking about is taking into consideration the percentage of nutrient that is actually in the fertilizer that we're purchasing, and we take that into consideration as we come up with the actual fertilizer rate that we're going to apply of whatever source we're using. In our example, we were using 1152O or MAP to come up with our recommendation for fertilizer. And finally, if you look at page 6 of the document that you have, we do have the blank forms that if you want to try a couple fields, see what your recommendations are, see how they work, please feel free to use those on a couple of your soil test recommendations. And one thing that I did forget was that on page 5 we actually have everything filled out and kind of a reference back to what source the recommendation came from, and then how to calculate that fertilizer need. So hopefully that will get you down the road to having phosphorus understanding and what kind of recommendations on your farm will work for your production system. As always, appreciate your time and thank you.